Hello, I'm Matthew Shealy, a senior at Atkins High School. I'm also president of our Alternative Fuels Club, which is trying to build our own efficient electric vehicle to compete in the Shell Eco Marathon. This is a course of streets that are going to be blocked off in Sonoma, California. The course is going to be between 5 and 7 miles long, but instead of racing to see who can get around the track the fastest, we're trying to see who can complete the course and use the smallest amount of electricity. So why would we bother? The answer is cost. The average gasoline vehicle in the United States consumes almost 11 cents per mile of fuel, whereas the average electric car consumes only about 4 cents per mile. Electric cars also generally require a lot less maintenance than gasoline vehicles, which further reduces their cost. Unfortunately, the limited range and high cost of electric vehicles can prevent their usefulness in many scenarios. Increasing efficiency would let a vehicle travel farther on a single charge, and that would allow for more applicable uses for these vehicles. Why should something as essential to modern society as reliable transportation be as expensive and complicated as a gasoline car? That's the problem that we're aiming to solve. One of the most innovative components of our vehicle is the motor controller. After learning how to design circuit boards from local electrical professionals, members of our team designed, assembled, and programmed our own motor controller. This allows us to carefully control power consumption, as we can carefully regulate certain parameters that significantly increase efficiency. Our goal is to consume as little energy as possible, and each time we make a development on the controller, our vehicle can go farther on a charge with hardly any cost increase. In addition to designing and assembling hardware, our team is learning how to program the microprocessor on our motor controller. We can build in features that keep the speed within competition guidelines, minimize power consumption, and automatically limit forces to reduce energy consumption and wear on the components. Changes made to the controller's code don't require any hardware changes, so there's no cost increase for modifying the program. We were also able to analyze the efficiency of our motor and controller by measuring the electrical power we consumed versus the mechanical power we got out. This data showed us that the motor is up to 90% efficient at lower speeds, while this quickly falls to less than 70% when the speed is increased slightly. Using these results, we were able to select a wheel that keeps our motor in its most efficient range during the speeds that we'll encounter at the competition. We also had to consider the weight of our vehicle when performing these calculations. We're welding our own chassis and pulling our own fiberglass body, so we're aware of all of the materials that are going into our go-kart. Similar testing scenarios to this one can lead to choosing efficient wheel sizes for full-size vehicles as well as our smaller car. We've also been invited to many local events relating to electric vehicles and innovative technologies. From talking to other electric vehicle pioneers at the Triad Electric Vehicle Association's Odyssey convention, to showcasing our motor controller at the Wake Forest University Tech Exploration event, we're able to see the progress that other groups have made while demonstrating the innovation that's possible at the high school level. I just wanted to thank our sponsors, R.J. Reynolds, Laughlin Enterprises, Wake Forest University, Green Cycle Design, and of course all of our club's parents. If you have any questions, feel free to stop by our table after the presentation.